Welcome back to another video, and in this video I will show you programming the test cartridge. I made this test cartridge over here. I'm using the VHDL6526 that I have made before, but I can easily put it in and out. And I'm programming I'm using the emulator to program. So last night I spoke with Wouter. He told me about this program C64Studio, and he's also using it on his YouTube channel, the Highlander. So he says it has a good debugger, so I wanted to try it. I haven't had trouble with it, but how do I make a cartridge? So maybe some of you, my viewers, know how to make a cartridge. So basically Wouter told me that I could right click my file up here and then do properties, and then in here you could select what kind of compile target you want, and they have a 8K cartridge here in bin or CRT. So I'm gonna try that. It doesn't work with the ultimate mode for some reason. So thank you very much, Wouter. He has now helped me, and we have gotten this to work. So the thing here, I think there was something in the help file. You can press F1 and get help, and then we found something called 2, and if you set 2 to the file you want, you can actually define ultimax 8 cartridge. So that was missing. So why can't you select that up here, like here for example? Why can't you say 8K cart? So, but if I press parse the target, you get an error message, which is, yeah, maybe it's it's just not in there. It's supposed to be in there. Now it crashed there also. So, and we couldn't get the compiling to work either, or debugging. So I also tested the files here, the CRT files that the C64Studio produced. Still didn't get the correct file. So if you write cart, you will see that the cart convert, and then look at the file type, we saw that it started at the wrong address. So what you can do then is to properties, compile target, and just select none for some weird reason, or else this will butt out on the file that you have written in here. So, and don't press parse target, it will crash. So and then debug, I select the AK cartridge CRT and the CRT file, and it has to be the same as you have written here. So now I can press compile, it works, and then I can do rebuild, and then you can actually see the output. It's actually building, and I can also run it. There you go. It looks weird. So figure out what's going on there. But I can also do build and debug, which is really nice. So now if I select a breakpoint, let's say I want to see how it fills memory with a clear screen. I can break here. I can start the debugger. So, and then I can click memory, and then we can go down to 400 or 0400. There you go. Now you can see there's a lot of garbage. This is a typical pattern for WinWise. So if you now do single stepping, now it loads here. You can see now we got 20. And you can continue like this. This code is like it writes to every page, and then it reboots sort of. So I think that's, maybe it's fast or something. Now it writes to color memory. And then when it comes to branch not equal, then sometimes it crashes, sometimes it continues. I have no idea what it's doing. It's opening a disassembly for some reason. You can see that again. If you know why it does that, it would be cool to know. However, if I click again, it continues. So what I can do now is that I want to see what happens in the memory when it's finished. So then I can remove the breakpoint and move to the next instruction after the loop, and then I can run it. Look, there we go, 20, 20, 20 all the way. And I think, okay, so it's pulling the Vice emulator here. And there you can see at 800 we get those char set things, so that's cool. And I also checked that the char set is correct. So if I want now, I can exit like this. But thank you very much, Water. So now I can debug it. And this is the state of the program now. I've gotten quite far. So we'll see what I will do. I'll probably start using C64Studio, because then I have much better tools when if I get stuck and I have to debug something. So. I posted a picture on Twitter where I was testing port A and B. I showed this image where I had a routine where I asked people, what am I doing here? I thought it was a bit funny, this function. The theory is that I connect port A and B together, pin by pin, and then I run a bit through them, one by one. So all of them are 0 except 1. So I set port B and I compare port A, and then I do the other way. So, but then I found a bug. So many of you got it right who answered on Twitter though, by the way. But I found a bug. So, and I will show you very shortly. So now you know that what I'm doing in this routine is that I'm first I'm setting up the ports. I'm setting one port to be output, the other one to be input. Then I'm loading the accumulator with 1, and then I'm moving that bit by rolling it to the left. And then here, when that bit has reached bit number 7 and it rolls into the carry, and therefore it no longer is cleared. The carry is not cleared. Then it's set, so therefore it continues. So, but if it's clear, then it will just stay in the loop. So and at the same time I'm using that value to compare though. So, and in this function, it's I'm setting a red color for error, and if all goes okay, it will then be set to green. However, if there's a comparison that it's not matching, oops, sorry, this is just not the code. I will show you shortly why I do this. And so if compare A is not matching the accumulator anymore, or what we stored on B, then it will jump out and it will keep the red color. So, but I thought maybe that was a bit, okay, I get a red, right? So let me show you the actual computer screen, what I'm showing. So if the test goes wrong, this text will be red, and so will the other tests. So these are 2 tests, but I also want to see which bits are wrong, right? Because I'm testing every individual pin on the port. So we'll get back to that very shortly. But first, let's look at that bug. So to test this, it would be fun to debug it. And now I get to show you that. So what I do, click the main program here, and then I click debug. Now it's running in the background. It's halted, therefore it's a bit slow. There it is. Yes, you see it stopped at port 6 there. Alright, so we are here. So we put the, you can see the accumulator up here on top of the screen there. I think I will bring the watch pane in here also, so it will be easier to follow everything on screen. Alright, so let's load the accumulator. Now we can see the accumulator has that bit I was wanting to push through the whole thing. Now the reason why I'm doing a clear carry here on the next one is because I don't know who is setting it, but it doesn't matter. We want carry to be clear because we want this bit here to be the one that stopped the loop. Okay, so it was actually never set here, so it's in the status here, so it's already clear. So what I'm doing now, I'm putting that accumulator, which is 1, in on port B. So we drive one of the pins like this, and we can actually watch that one if you like this, add a watch. Yeah, without leading zeros. I don't know why they're not showing leading zeros. So let's just go to hex then, it's more useful. Okay, so I'm putting a 1 on port B, and that means when I compare with A, you should see the same thing. But since this is a emulation, I'm afraid it doesn't show. So what happened now in the compare is that we didn't get a 0 flag. That means it wasn't equal. Therefore, this function will now not equal, will jump to continue, which is down here. So that means that the test failed. There you go. So now it will load the text and print it and so on. So let's just stop it. Now let me show you the bug. Let's see. Now let's pay close attention here. Okay, stop. Now I did notice the bug when I removed this compare with A with something that was fixed to 1. So the first test will be correct, and then the second test, when the accumulator moves the bit, will then fail. So, but when it's correct, there was something wrong here. So let's have a look. Alright, accumulator is 1, storing that. And now I'm sort of simulating that we have a 1 on port A. I just say compare 1. Let's see what happens. Alright, so we have the 0 flag over here. And then the test will then go into roll. I will roll that bit. Let's see what happens. But before I do that, pay close attention to carry. Why do I carry here? Let's find out. So what happens now if I rotate right is that, okay, this bit will go right, so it goes to 2 in the accumulator, but this carry will then go to bit 0. So look, it goes to 3 instead of 2. Oh, so there you have a bug. It's supposed to go to 1, 2, 4, 8, and then 1, 2, 4, 8. So let's see if we can catch that bug. Start it over. Load the accumulator with 1. Nothing wrong here. We have the accumulator 1 here. Store it on the port. You see the status register doesn't have 0 or clear. And then when you do the compare, oh, we get a carry. Clear. I said clear, sorry. Carry. Damn it. So there's a bug there. So right here in the test, it's no problem having that bug. But it's the roll that we want to know if we have a carry or not after the roll. So to fix it, I can fix it.
I can fix it!
Let's change the code. There's many ways of doing this, but I'm going to just clear the carry here before we do the actual carry test by rolling. So that will do for now. So like this. Let's go again. Accumulator 1, carry clear, store on port B, compare with 1. Let's see, we got a carry here, and we also get a 0. So that means that we will not continue, we'll actually continue, because yes, the accumulator was 1 and it compared with 1, so that will be okay. We'll test the next bit. Pay close attention to carry up here. Now we do a clear carry No surprise there. Carry's gone. Let's rotate. Ah, the accumulator is now at 2, not at 3. So that's good, because it went to 3. So in the other, before we remove that bug. So now it will store a value x2 on the port. Okay, so this time we do the compare. It will not compare, because now the accumulator is 2. So this is just the way this works, because now we are comparing with a fixed number. So therefore it will jump out like this and then print the text on the screen. So there we go. But now I do also want to do another thing. I want to actually show on the screen which bits are wrong and which are not. And then I was thinking, okay, let's put that in parameter 1, so we'll see which bits are wrong or not. So let's try that. So first I'm just going to clear all the bits. Store it in the parameter 1, which is just a location in memory. And then I'm gonna, right, so instead of jumping to continue, I'm just going to jumping to not match. We are also going to have a label that is nobody is jumping to. But if it is a match, then we'll just follow here. And if there's no match, we will go here. Right, so if there's no match, we will then set the bit. But this will not work, so I think we need to do something like this. So let's try that. Now I want to put whatever's in the accumulator on parameter 1. So, or parameter 1 with the accumulator. We get a lot of bits that are already set in parameter 1, so we need to also store that back in parameter 1. But the problem now that we have broken this rule we had, that we are moving a 1 through the whole bit thing. So therefore I first push it on stack, and then I do all the operation I need, and then I can pull it back again. So let's see if that works. Alright, so the first test match, so it actually did jump like it was supposed to, and the accumulator is 1. But the second test, now when the accumulator is 2, compare with 1, it will fail. So there you see, it will just go into no match. We don't want to lose that bit pattern, so therefore I push it on stack. You can actually see the stack if you want, but it's not that interesting. We'll then OR it with whatever is in parameter 1, which is now 0 down here, you can see. Let's see what happens. Okay, the accumulator is still 2 because everything was 0 on the parameter 1. So let's see what happens when you store it. There we go. We got that bit in there, indicating that we had a mistake there. So instead of doing this for all the 8 bits, I will then just let it run through the whole loop. Press play up here, down there. Now you can see that the first bit was okay, but the rest was wrong. That's because we're comparing the same pattern all over. But in the real test, I'm hoping that all of this will be 0, And now I can also show on the screen what was wrong. So now we have all the answers in parameter 1. So let's just print it then. So what I do then, I load parameter 1, and then I call print text, and then I put a space in between here. So let's see what that looks like. I don't know why it's green now, but I have to maybe look at colors, because it's not supposed to be green before this number is 0, because if it's 0, then we don't have any errors. But if it shows FE, that means only the first test was correct. So because then the first bit or 0th bit is 0. So that's it.